Okay, so let's talk about graphing basic exponential functions. And we spoke about it in the last video that we have y equals ab to the x, where a is your y-intercept or starting value. If you want to know why, make sure you watch that last video. So a is the y-intercept or starting value. B is your multiplier, or another word for multiplier was your base. So that's your b value. X is your independent variable, and your independent variable is here the exponent. And Y is your dependent variable. We'll use a different color here. Y is your dependent variable, which is your end result. Y is dependent on X. It's important. Okay, so let's talk about graphing these. Basically, we're going to go as basic as possible. We are going to make a table. And we don't need to put 1.5 million values into a table. We can just do just 5 values for the first one, and then really we'll do only 3 for the rest of them. But what we're going to do is we are going to put 0 in the middle, and then we're going to do -1, -2, 1, and 2. And let's see what the behavior of the graph is going to look like. So 3 to the 0 power. So we spoke about this again before. 3 to the 0. So this is equals to 3 to the x, right? 3 to the 0 power is equal to anything to the 0 power is equal to 1. So my point here is 0, 1. So I'm going to plot that right here. Let me make it a little bit more. 0, 1. Okay, let me put some ticks. Okay, so what if I have 3? Let's go to the positives because positives are easier. 3 to the first power. 3 to the first power, because I'm plugging in 1, right? 3 to this power. 3 to the first power. 3 to the first power is just 3. So my point here is 0, 3. And so I'm going to plug that in. I mean, not 0, 3. I'm sorry. It is 1, 3. 1, 3. And so 1, 3. There is my point. Next is going to be 3 to the, right here, to the second power, which is going to be 9, right? 3 times 3 is 9. So it's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. The point right there is 2, 9. What about if we go to the negatives? So we have 3 to the -1 power. And we spoke about this in class, that when you have something to the negative power, this is not its happy place. It is negative here. So this is technically x to the -1 over 1. So this needs to go to its happy place. It needs to become positive. So it's going to go down to the bottom and become positive. It's like it's going downstairs. Downstairs is his happy place. Upstairs, he's miserable. So it's going to be 1 over x to the first, right? If I have x to the -2nd, it's going to become 1 over x to the +2nd. So that's what a negative exponent does. It turns it into a fraction. So this is the same thing as saying 1 over 3 to the first, which is just the same thing as saying 1 over 3. So my point here is -1 and 1/3. So you're not going to be able to see it that well, but let's just put it here, 1/3. And then I'm going to have 3 to the -2nd, which is, what's 3 to the second? So it's going to be 1 over 3 to the second, which is 1 over, and 3 to the second we know from here is 9. So it's going to be -2, 1 over 9. And again, it's going to become even more, even closer to the x-axis, because 1/9 is smaller than 1/3. And so notice what's happening here. Notice how it's going to infinitely, infinitely, infinitely get closer to what is called an asymptote. A horizontal, you know what, let me put this in a different color. A horizontal asymptote. Now, we are not going to deal with horizontal asymptotes other than 0 for right now. So just know that our horizontal asymptote for any basic function, so for y equals ab to the x, my horizontal asymptote is y equals 0. This line right here is y equals 0, which by definition, the horizontal asymptote is a line that the function infinitely gets closer to, but will never, ever touch or cross. So this is what the function is going to look like. It looks like it's kind of like riding along the asymptote, but it's actually getting closer and closer to it. Then all of a sudden it goes up and then it skyrockets. So it's getting small, like it's like infinitesimally getting smaller and smaller this way, but then over here it's skyrocketing. And there's our graph. So let's try another one. Y equals 2 times 5 to the x. So I'm going to make my equals 2 times 5 to the x. So the first thing I'm going to do, let's put this in red. So the first thing I'm going to do is I'm going to put my values in, but I'm only going to do -1, 0, and 1. And when you do your Khan Academy exercises, you'll see that you're going to be asked to graph some of these, and you're really only going to need 2 points, and I'm going to show you which points you're going to want to put in with the next example. But let's do all 3 of these. So always start with 0. When I plug in 0, I get 2 times 5 to the 0 power. Now, order of operations. Do I do 2 times 5 first, or do I do 5 to the 0 first? I'm going to do my exponent first. And this x is only, the exponent is only to the 5. It is not to the 2 also. So this is the same thing as saying 2 times 5 to the 0 power. And what is 5 to the 0 power? Well, anything to the 0 power is 1. So this is 2 times 1, which is equal to 2. Now, we could have already known this because when we spoke about this to begin with, this is always our y-intercept. So 0a, which is 2, is always going to be a point. Now here, my a value doesn't look like there is one, but there is, right? Technically, my a value is 1. It's 1 times, and that's why this 1 is here. So this is 0, 2. So let's put that. 0, 2. Okay. Now let's plug in 1. So we have 2 times 5 to the first power. Now we do the 5 to the first. So we have 5 to the first power. 5 once is just 5. And 2 times 5 is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my point goes right there. See how it's growing faster? It's growing faster for 2 reasons. One is the fact that the 5 is bigger than the 3 here, right? So 5, that means it's growing at a quicker rate. Also, it's being multiplied by 2. So instead of being multiplied by 1, it's being multiplied by 2. There are 2 reasons why it is growing at a faster rate. Next, let's do 2, -1. So 2 times 5 to the -1 power. Now, what did we say is 5 to the -1 power? It is 1 over 5. So it's 2 times 1 over 5. And so 2 times 1 over 5 is the same thing as saying 2 over 1 times 1 over 5. And so that's 2 over 5. So here my point was 110, and here it is -1 2/5. So 2/5 is a little bit less than half. So it's going to be -1 and then 2/5. And again, my horizontal asymptote my horizontal asymptote I know it's an ugly word, but we'll get over it, is y equals 0. So it's infinitely approaching that line, but it is never touching it. And so it's going to look something like, and then it skyrockets at a much faster rate. Okay, and one last one. So immediately, when you're going to do these problems online, you already know that immediately. I know 0, 12. Immediately. This goes with 0 because this to the 0 is 1. 1 times 12 is 12. That is going to be an immediate response. Okay. Then when you're doing the Khan Academies, you're just going to want to plug 1 in and find out what that second point is. So I'm going to have 12 times 1/2 to the first power. Anything to the first power is just itself. So this is 12 times 1/2. What's 12? What's half of 12? Half of 12 is 6. So I have 0, 12. We already figured that out, right? And then we have 1, 6. And then my last one, because I want to have that third point. Again, you're not going to need that on the Khan Academies, is 1/2 to the -1 power. Now, again, the -1 power flips it, right? So this, I'm going to write this down here. 1/2 to the -1 power is the same thing as kind of saying, actually, it's the exact same thing as saying 1 to the -1 over 2 to the -1. I just distributed that -1. Both of these hate where they are, so they need to become positive on the other end, so they just flip, and they become positive. So it becomes 2 to the first over 1 to the first, which is 2 over 1, which is 2. All I did was flip them. So 1/2 to the -1 power is just 2 over 1. This is just the long way of explaining it, but it's just the reciprocal. So if I had 2/3 to the -1 power, it would be 3 over 2. You just flip it. So this becomes 12 times 2 over 1, which is 2, which is 24. Now, how do I know from these two problems that they were going to be growth? Immediately, I know they're going to be growth, as I explained in the last video, that this 3 right here is greater than 1. This 5 right here is greater than 1. What is this one going to be? It is going to be decay. Immediately, I know that this is going to be decay because 1/2 is less than 1. So because of that, it needs to look like this. Instead of the other ones that look like this one needs to look like a plane landing, not a plane taking off. So let's see. Let's graph it. So we have -124. Let's graph these 3 points. 1, 2, 3. So this is going to be not the greatest graph ever because it is, let's go by 2s. 2, these are going to go by 1s. And then these are going to go by 1s. So 1, 2, 3. These are going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay? So 2, 4. So I have 1, 6. 2, 4, 6. I have 0, 12. 2, 4, 6, 8, 10, 12. And then I have, immediately I see that it's decreasing, right? But then I have -1, 24. And then this is going to be -1, 24. So that's going to be somewhere up here. This is very steep, but you can see the decay. If we plugged in, let's say we plugged in 2 just for the sake of seeing where it's going to go. So if I have 12 times 1/2 squared, right, this becomes 1 over 4. So 12 times 1 over 4, 12 divided by 4 is equal to 3. So this would have actually been 2 3. Yeah, right there. So it's important when you're doing these, and I actually have um, the Khan Academy. When you're doing these, you're going to plug in immediately. You are going to do um, your y-intercept, which is your b value. Okay, that's important. Is it just this? I mean, your a value. I'm sorry, your a value. That's going to be put first, and then you're going to just plug 1 in. So these are the 2 points right here that you're going to want to use to do your Khan Academy assignment.